Hi, this is Cliff Nelson from Redwood Tutoring. I'd like to talk with you about part 4 of my series on logarithms. I'd like to talk with you about the natural logarithm. Well, let me first introduce you to a number. This number is called e, and it comes up a lot in different applications. Now, e is a number. It's what they call an irrational number. That is, if I was to express it as a decimal, it would go on and on forever, never terminating and never repeating. Now, if I was to round it to one decimal place, e is approximately equal to 2.7. Now, when you see ln of x, all that this means is log base e of x. ln of x means just log base e of x, using that number e. So if I have this ln is what it's called because it's the natural log. The natural log. And this is something that's going to be very useful for us in solving equations and doing applications. Let me go ahead and show you what I mean, but let me clear off some board space first. Suppose that I want to solve the following equations. I want to solve the natural log of x equals 2. Well, I think that what we should do first is just rewrite it. This is the same as log base e of x equals 2. And I want to bring you guys back to our very first lesson on logarithms, where we talked about converting to exponential form, and we said that there was this nice counterclockwise cyclical motion. Well, in order to convert this into exponential form, this is just e squared, e to the second power, equals x. So my final answer, plugging this into the calculator, would give me x is approximately equal to 7.389, only approximately because the decimal actually goes on forever. But this is just approximating it to 3 decimal places. Now, let's suppose that I have a problem that looks like this. I'll just draw a barrier here. And suppose that I have 2 times the natural log of x equals -8. Well, before I do anything else, I need to just rewrite this. I need to get the 2 onto the other side. I'm going to divide both sides by 2, and this is going to give me the natural log of x equals -4. And we saw from this part that that's the same as log base e of x equals -4. And then I do that same counterclockwise cyclical motion to get me to exponential form. This is going to be e to the -4th power equals x. Plugging this into my calculator is going to give me x is approximately equal to 0.018. 0.018. Now, let's go ahead and do a different looking problem. Suppose that I have 5 to the x equals 7. Well, if it was 5 to the x equals 25, or some nice power of 5, then that would be something that I could maybe just do in my head. But it's hard to see 5 to what power gives me 7. Now here's the trick. I'm going to go ahead and rewrite that equation. 5 to the x equals, leave some space, 7. And then I'm going to take the natural log of both sides. Now, I want you guys to recall this property from one of our 3 properties that we talked about in a previous lesson. that if I happen to have log base b of x to the rth power, then what I could do is I could bring that r down in front, and so this would be equal to r times log base b of x. Well, the whole reason that I took the natural log of both sides is so that I'd be able to use that property to get this x down here. So this is going to give me x times the natural log of 5 equals the natural log of 7. Now, looks like I'm almost done. All I have to do is divide both sides by the natural log of 5. This is going to allow these two to cancel out. I'm going to get x equals the natural log of 7 over the natural log of 5. Plugging this into the calculator and rounding to 3 decimal places gives me that x is approximately equal to 1.209. Now, it's also useful for us to just verify and make sure that that works. So for a check, I recommend that you plug this into the calculator. Instead of x, type in 1.209. See if 5 raised to the 1.209 is approximately equal to 7. I only say approximately because x is only approximately equal to this, so my answer is only approximately going to be equal to 7. Sure enough, if you plug this into your calculator, you're going to get something very close to 7. So that's going to work out. Now, let me just do one last problem. This will be problem number 4 in this lesson. Let's say that the equation goes like this: 12 equals 2 to the x minus 3. Well, before I do anything else, I need to isolate the exponential expression. I need to isolate 2 to the x. I want to bring this 3 onto the other side. I need to add 3 to both sides. This is going to give me 15 equals 2 to the x. Now what I'm going to do is use the same trick that we did in the last problem. I'm going to take the natural log of both sides. The natural log of 15 equals the natural log of 2 to the x power. And then what I'm going to be able to do is take advantage of that property that allows me to bring this exponent down out in front. And what I'm going to have here is I'm going to have the natural log of 15 equals x times the natural log of 2. So dividing both sides by the natural log of 2, this allows these two numbers to cancel each other out, and then I'm going to get x is approximately equal to, plugging this into the calculator, you get x is approximately equal to 3.907. Now, to verify that this is in fact my solution, what I'm going to do is I'm going to go back to the original equation, and what I'm going to do is I'm going to plug in x onto the right-hand side and just make sure that I get something that's approximately equal to 12. Well, if I do 2 raised to the 3.907 minus 3, plugging that into your calculator will give you something close to 12. Surely that works out. Sure enough, that works out, and that gives us our final answer. This is Cliff Nelson from Redwood Tutoring. Thank you for joining me.